So one last example with curve sketching. Let's say that y is equal to sine squared of x. Remember what this means. This is the function sine of x squared. And we'll restrict our domain to go from 0 to 2 pi. So our steps in sketching this graph: first we take its derivative, then we take its second derivative. We find out where the first derivative is 0 and use that to plot its sine graph. We find where the second derivative is 0, use that to plot its sine graph. Then we'll use all that information to plot the graph itself. So first step, computing the derivative, dy dx. Well, this is sine squared, so we've got a chain rule. So it's 2 times the derivative of the inside. So we need to take the derivative of sine. So 2 times the derivative of sine, which would give us derivative of sine is cosine, times this whole thing, because we did a power rule, so the 2 came down, and this reduces by 1, so it ends up being sine of x. That's what the first derivative gives us. The second derivative, well, now we have a product rule, right? We've got cosine times sine. So this will be 2 times the derivative of sine, which is cosine, so we get a cosine squared. And then 2 times the derivative of cosine, which is negative sine, so that's a minus 2 sine squared. Okay, so we've computed our first derivative, we computed our second derivative. Now we need to look at when is the second derivative, or sorry, the first derivative 0. So when does this equal 0? Well, it's when either cosine or sine is 0. So this means that cosine of x is 0 or sine of x is 0. Well, we know cosine of x is 0 at pi over 2 and 3 pi over 2, and sine of x is 0 at both 0 and 2 pi. So this means that x is in the set 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right? Those 0, pi, and 2 pi is when sine is 0. Pi over 2 and 3 pi over 2 is when cosine is 0. So doing the sine graph for f prime, we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now these are our endpoints, but they're also points where the function is 0. So I can't use them as my checkpoints, because if I put them in the function, right, if I put 0 into my function, I would get 0. So I'm going to have to use values in between. So some easy values would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And I'm going to leave it for you to evaluate all these values. Just remember that cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. If we come over here, we're in the second quadrant, and so cosine is negative and sine is positive. In the third quadrant, which we are here at 5 pi over 4, cosine is negative and sine is negative. And then finally in the fourth quadrant, cosine is positive and sine is negative. So even if you didn't know the value of cosine and sine at pi over 4, you would know which quadrant it's in, and we're just multiplying cosine and sine. So in this first quadrant, cosine times sine is positive. In the second quadrant, where cosine is negative and sine is positive, their product is negative. In the third quadrant, where they're both negative, their product will be positive. And in the fourth quadrant, where cosine's positive and sine is negative, their product will be negative. So we know that the function between 0 and pi over 2 is increasing. Then it will be decreasing between pi over 2 and pi. Then it will be decreasing, then increasing between pi and 3 pi over 2, and decreasing in this interval. So that's increasing, decreasing business. How about the second derivative? When is it 0, or when does it not exist? Well, this is when, so solving this out, we need that cosine squared has to equal sine squared. Or taking square roots of both sides, it's when cosine of x is the same as either plus or minus sine of x. And those are only, well, actually, it's the values we picked here, the easy values for here. This is when x is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So if I make my sine graph for f double prime, we're going from the interval 0 to 2 pi. We're going to look at our points of inflection, so pi over 4, 3 pi over 4, 5 pi over 4, and then finally 7 pi over 4. So now since 0 is not a place that makes it, I can use that as a checkpoint. Then between pi over 4 and 3 pi over 4, there's a really nice value, pi over 2 I can check. Between 3 pi over 4 and 5 over pi, there's a nice value, pi. And then finally here, there's a nice value, 3 pi over 2. And the last interval, I'll use 2 pi as my check. So if I put 0, so this is my function, right? This is my second derivative. I've got to put 0 in for this. Well, 0 for cosine is 1 and sine is 0. So we're positive in this first interval. In the second interval, from pi over to 3 pi over 4, I'll use my check value of pi over 2. If I put that in, cosine is 0 and sine is 1, so this is negative because I'm subtracting sine. If I put pi in, cosine is negative 1, and this is 0, but of course we're squaring it, so it becomes positive. Between here, I put 3 pi over 2, cosine is 0, sine is negative 1, but again we're squaring it, so this is negative. And then finally at 2 pi, cosine is 1, sine is 0, so it's positive. So we've got a lot of changes going on. It's concave down in this interval, concave, or whoops, let's try that again. It's positive, so it's concave up, it's concave down here, it's concave up, it's concave down here, and concave up. So finally, we need to evaluate our function at some of these key spots before we graph it. So our interesting x values, we've got a lot of them in this example. So we've got what is the value of y, and remember this is the function sine squared. And we want to know what is the value at 0, at pi over 4, at pi over 2, at 3 pi over 4, at pi, at 5 pi over 4, at 3 pi over 2, at 7 pi over 4, and then at the endpoint 2 pi. So we've got a lot of places to evaluate, and just to help us keep track, let's circle the ones that are critical values. We'll mark critical values in green. So this is a critical value, this is a critical value, critical value, critical value, critical value. Those are all critical values where the derivative is 0. The other spots are points of inflection, so I won't mark those. So putting 0 into sine, we get 0. Putting pi over 4 into sine, we get root 2 over 2. Then if we square it, that's 2 over 4, or 1/2. If I put pi over 2 into here, I get a 1 squared, which is 1. If I put 3 pi over 4 into here, again, I get root 2 over 2 squared, and so that's 1/2. If I put pi into here, I get 0. If I put 5 pi into sine, I get negative root 2 over 2. Squaring it gives me 1/2. If I put 3 pi over 2 into sine, I get a negative 1. Squaring it gives me a 1. If I put 7 pi, I get a negative root 2 over 2. Squaring it gives me 1/2. And put 2 pi in here, I get 0 again. So let's take all this information and plot the graph. So all the key spots that we need to pay attention to, we've got an endpoint here at 0. We've got our other endpoint here at 2 pi. We know halfway in between pi is a good spot. And halfway in between pi over 2 and halfway between here, 3 pi over 2. And then we have all their halves, so pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. At 0, we're 0. This is the value 1. This should be the value 1/2. So at 0, we're 0. At pi over 4, we're 1/2. At pi over 2, we are 0, or 1. At 3 pi over 4, we're 1/2. At pi, we're 0 again. At 5 pi over 4, we're 1/2. At 3 pi over 2, we're 1 again. At 7 pi over 2, it's 1/2. And at 2 pi, we're 0. And putting in our slopes, here the slope, this is a critical value, so the slope is 0. Here the value is increasing. Here the slope is 0. Here the slope is negative. Here the slope is 0. Here the slope is positive. Here the slope is 0, negative, and finally 0 again. So what does the graph have to look like? Well, it's going to have to start at a 0 slope and increase up. So it's a 0 slope, increases up, then it hits here and decreases down. Then it's a 0 slope, increases up, 0 slope, decreases down, and finally like that. And here's our local maximum, which is also our global maximums at 1. Here's, so if I just wanted to label things, here's our max. Here's another max. Here's where our mins happen. Here's another min. Here's another min. And we know that. And then our points of inflection are here, 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 and here, all points of inflection. Right? Those are our points of inflection. We've got max value of 1, min value of 0, points of inflection all occurring at pi over 4 or 1/2, yeah, pi over 4 1/2, 3 pi over 4 1/2, 5 pi over 4 1/2, 7 pi over 4 1/2. And that's where, as you can see when we made the graph, it changed from concave down to concave up through here, and then changed again from concave up to concave down, and then changed again, concave down to concave up, so on and so forth. So that's how we use derivatives to sketch the graph. Hope that helps. Happy mathing, and we'll see you next time.